Hello YouTube viewers, welcome to my channel Science to Technology. Today we're gonna start our big project of making a proper functional fume extractor, which hopefully many of you could replicate if you guys need it, because it's one of those things that you need, and if it's not done properly, yeah, you're not gonna use it. So that's how we started fume extractor. Okay, so one very important question that many of you have is like, how do you research and do not get stuck in a rabbit hole? Well, one very simple solution. What are you trying to make? Film extractor. Okay, do not look into other DIY projects. Nope. Directly go and look into tear downs of professional products that will allow you to clamp yourself to what is actually done. I looked into many videos, obviously, but majority of them are just flat out useless because they have a fan and they have a foam block that is a carbon foam block, and it's so sparse that light can go through, and I can guarantee you it's useless. So that's there. And sometimes they're using very small fans. It's like, why? So I looked into professional. What did I notice there? First, they generally have a big ass fan. However, the consequence there is that it's very loud. Many people, professional people who have the money, who have proper fume extractor tools, do not use it simply because of the noise. So noise became a red alert fact. And again, I also want to make sure that whatever I build is not so noisy that people are like, yeah, I'm not going to use it. So keeping that in mind, we started my search and figured things out. So one of the most important thing I noticed in all professional unit is that they never just have one thing. They have two things. So they have a filter, and then they have activated carbon blocks. Now filters, it's dependent on your location. Sometimes many of you can easily just buy HEPA filters. I could not. What I was looking for, I could not find in the size and all dimensions and all that. So, and they were ludicrously expensive, like way too expensive. And tiny ones were like, that was used for like vacuum motors. Only those were kind of affordable. So I was looking for something different. Now, let me be very clear. Professional units, they are awesome, but they are expensive as hell. Nobody buys them. And cheap ones are so cheap, they're almost useless. So I need something in middle. DIY suits this. So filter became the first thing to find out. Okay, so this is my solution. This is a Bosch cabin filter. Now here's the deal. You do not have to use this exact model. I'm just showing how I solve this issue. You may maybe lucky enough you can find something that is even thicker than this. Do not worry about black color. That is from activated carbon. Now, be mindful, all of the filters generally have an airflow direction. You must follow it. If you do not, you will clog it way too quickly. That is why the airflow directions are there. So this is there. Now, again, it's good. It's good. Again, it's designed for a good volume of air movement through. And this, all I needed to do, take care of the big puppies, big chunks. And gases will, of course, go through it. But what do we do with gases? Well, activated charcoal. These are the second thing. So this was my activated charcoal block that I use in my system. Now, design wise, I'm not that happy with it. Charcoal wise, I am really frustrated that I could not find any source of that granular charcoal. Turns out it's very difficult to make, because again, you make activated charcoal either by cooking coal or cooking charcoal. Now that's cool and all, you get activated, but here's the, how do you bind it so it does not crumble into dust? Turns out it's very difficult. That's why granule systems that do not turn to dust is very, very expensive. I could not even find a quality source which I could trust. I have seen a lot of people buying things that are from aquarium system, and turns out it's just rocks with a charcoal cover on top of it. I was like, no. So I looked into this system. It does work. Now, how do I know this works? There is no smell. It removed all the smell. So it works. Consequence, this puppy is dusty as hell. So I looked around, and for my Mark II variants, I have found a supplier that provides coconut husk that is converted into a system. So it's supposed to have less dust. Hopefully, we'll figure it out. And again, design wise, the biggest mess up I did in my design is that I did not basically, I trusted the airflow momentum rather than you have to seal everything, because air does not like to go through things. If you have a filter, air will like to go around it. If you have a charcoal block, it will like to go around it. It will leak rather than go through. Now, I have enough of it and enough momentum, enough that it does work, but it's not effective. And you can see this was my minimum viable product. And yeah, until I sealed the top one, I was literally seeing gases coming here. So yeah, that was a sloppy mistake on my end. Okay, so filter part sorted, activated carbon part sorted. Physically handling it, that is the second part. But as of now, I figured it out. Now, what about the fans? Now, this is where I went into a rabbit hole, unfortunately, but I learned a lot. So let's start with fans. Most people will try something like this. Now, these are 12-volt DC brushless fan. They are good, they are awesome, they work. But problem is, they do not have enough oomph because the RPM is low enough. And if you need high oomph, you need RPM. Look into server fans. You always need more RPM or thickness or both of them, practically both of them. So you need a lot of RPM and a lot of oomph. Now noise is the biggest issue. So you may be like, what if I buy PC fans? Good, awesome. So this basically was a tear down from a cooler master power supply. So originally I was using these things, very cheap fans, 1500 RPM. Unfortunately, they are from they have the RGB disease, and yeah, you cannot shut it off. It's like default, it will always glow, so waste energy on that. But it's there, it works. But I realized something very early on, is that this is barely enough. Thankfully, I put some cheap basically high power fans. These are local store bought fans. I have no idea which brand it is, some Chinesium brand, 12 volt, zero point 0.4 amps, but they are big, as in like 38 millimeter thickness rather than 25 millimeter thickness. Thicker boys, very high RPM, does have the oomph. Consequence, yeah, I'm back to square one, it's loud. So this is the easiest way to reduce noise while still maintaining airflow, is you use push pull configuration. So if you have a filter and you're like, I want one fan to push through it, it has to be very high RPM, like 5000 RPM. But if you have 3000 RPM fans, one the front, one in the back, now you can achieve the same thing without having the noise. So push full configuration it is, and I did it, and it does work. So that's all good and awesome. But in terms of structure, sloppy. This implementation, I have a 3D printer, but it's very slow, basic Ender 3. So I've designed something that was like very minimal printing. Yeah, sometimes, you try to be over smart, it backfires. And yeah, it took too much time. It's messy as hell. And I thought like these brace will work. I was feeling like engineer, and I built it as like dinky chica, is very sloppy, messy. Yeah, it did not work out. So again, this is a primary reason why Mark 1 is always garbage. It's supposed to be garbage. It does work. It does do what it's supposed to do. But this was just a learning for me. So next iteration, Mark 2 iteration, I'm going to redesign in CAD. That will be the next video, and properly talk about all the learnings I got, how to I get good enough air seal compared to this one. Let that be, I'm not going to like, full BOFA level, but better than this, good enough where it's like quiet enough and basically not causing air leakage as much as this one. Should be better. So okay, that gives the chassis a lot of mesh designs. This is much wider than it needs to. It has gaps. I did not understood. I cannot have gaps. It must be like as sandwiched as possible. So push-pull configuration solves the noise issue. But problem is, where do I get fans? Now, if you are in Western country, many places have places where you can get 3000 RPM fan. Arctic P15, if I'm not mistaken, Arctic series does have a quality PWM fans that goes to 3000 RPM. It has enough push-pull and it's quite enough. So you can, in push-pull configuration, and if you can throttle the speed a little bit, let's say to 2500 RPM, you will have a very quiet fan and have enough airflow that it actually works. That's awesome. Now, in India, it's just not available and very expensive. Even if those are available, I get it from abroad. So I went into a rabbit hole of fans, and damn, this is where I lost the plot. I went so deep that I actually understand now how these things work. Like this is an industrial fan. This is from AVC. AVC fan model DS12025B12UP024. Who the heck came up with this? But it's an industrial fan. Now this is 3000 RPM fan. That's a big deal because 3000 plus you start to reach into industrial territory or server territory. Price becomes stupid. Now this is very low cost. It's actually cheaper than many cooler master fan. Then you're like, what's the penalty? Sound. All the company manufacturing PC fans, they work their ass off to sound dampen it. Industrial one, they make the cheapest and most robust as they can make it. So they have cost competitiveness, but noise wise, yeah, it's painful. So if you want to use something industrial like this, you have to throttle them. Now, old school fans like This is a very old school cooler master fan. It has 3 pins. So you have basically black ground, you have red 12 volt positive, yellow tachometer output. So what we used to do to control these puppy is just reduce the voltage. Consequence, you need a circuit that tones the voltage down, which again, for little bit of electricity, it's not an issue. But once you start to talk about fans that are consuming 1 amp and you are talking about 4 fans, and again, the fans that I bought maybe actually higher than this also. So yeah, now you're talking about something that consumes a lot of energy. Doing DC voltage control on that, yeah, not good. And not to mention, it's not desirable. That's why 4-pin fans are invented in late 90s. By 2006, it became a standard in ATX computer. So idea is same thing. You have black, that is ground. You have red, that is 12 volt positive. You have yellow, that is tachometer. Now be mindful, tachometer output, it looks like PWM. It's not PWM. It's just a signal that transitions, and your computer counts the transition, and then it runs the formula, basically divide by 2 or multiply by 30, and then you get the RPM. I will show you it in oscilloscope during the electrical section of this project. And that's how these systems used to know, like this is was the feedback for the motherboard. Motherboard will try to reduce the voltage, and if it reduce the voltage, the fan is not rotating, tachometer signal will be like, hey, I'm not rotating. Computer can look into it and it's like, okay, I got it. And this is how computer knows that, like, how the heck do you think BIOS knows that fan is missing? It's not the 12 voltage positive, it's the yellow tachometer output. So using the tachometer signal, it can figure it out. Do you have a fan? B, is the fan rotating? So that's how it works. But for high industrial system, you just put 12 volt in, you do not touch the wire. And then you read the tachometer output if you need to, but then there is a blue wire. This is the 4th pin. Now 4th pin, again, PWM fans, very common things. You must have paid attention to nowadays. And yeah, they are backwards compatible. But the PWM signal is 25 kilohertz signal, 0 to 5 volt. The amplitude is 0 to 5 volt. Frequency is 25 kilohertz. I have already made a short about that. Now, benefit is that duty cycle of that frequency tells the controller here, the controller chip in the motor, how to rotate, like how much do you rotate. For example, if this had a PWM, the PWM is from 0 to 100. So this fan could be like, let's say 0 RPM to 1000 RPM. It will be like, okay, at 0, 0. At 100%, 1000 RPM. With this, it could be like minimum is 700, maximum is like minimum 0, 700, maximum, let's say, in this case 1500. So when the PWM signal goes to 0, this will go to as low as it can go, and as high as it can go. So that's how modern systems work. Same here. Now this is a much higher range system. I think the lowest is 700, highest is 3000. These puppies are loud. But again, that's the easy way of controlling it. How do you get a PWM signal? I thought of trying with Arduino, but then I realized Arduino and ESP32 has almost same price. ESP32 natively supports it. So I built this puppy. Yes, it does work. Again, another part, I'll talk deep dive into the electronics. So I have a potentiometer, a 25 kilohertz signal output, and voila, I can control the fan with pulse width modulation. I do not have to touch the power rail. I do not have to do anything to them. Simple, elegant, just works. And if you have paid attention to many high-end fans, they are claiming 0 RPM. It simply means it actually has an off mode. So if I have an Octava fan, it does have that 0 RPM mode. That simply means if the PWM signal drops below 20%, it assumes that computer wants me to turn off. So it turns off. So if you see any GPUs that have like 0 RPM fan or power supply fans, that's what it means. So PWM signal generator gives them the ability. It's like just put 12 volt, do not touch that. Tachometer output just as a feedback loop, and PWM as throttle. Basically now you have basically a feedback and accelerator, where it's like, okay, do I need it? No, I don't need it. Okay, but it does require the controller here to be 0 RPM. Be mindful, if you do not have 0 RPM controller here, don't expect it to work. And again, many times controller is the same. There are very few companies that actually make the microchip that goes in this. So those microchips could be there. If you know electronics well enough, you may be able to just like sometimes maybe lucky enough where you're like, oh, solder this resistor to this value, and you're like, okay, now it has activated that function. Do not try to do that. It's too tedious. And be mindful, pulling the fan blades out, that is doable in many fans, unless you have very cheap ones like this one. Yeah, you cannot pull it out. I tried, like remove the sticker, there is nothing there. Thankfully, many other fans have that, like where you can just open the back side, and then you will see a small clip that you can pull out. I love this one where you can actually pull out. Why? It's the easiest way to clean it. You pull it out, clean the damn thing, oil it, especially after 5-6 years, just little bit of oil, done. This is our industrial fan. Again, this also has a system, and it has dual bearings. Actually, I may be able to replace the bearings if it wears out, but it's a very beefy system. I doubt it I will ever need to do so. So this was the whole point. I went down a rabbit hole, learned a lot about fans. I'm very happy about it, and I'm gonna make Mark II. My core focus is making a much better chassis, and another thing is using PWM signal to just make a system where I can throttle the fans. And I have placed order for 4 of bigger versions of this. Bigger as in, like, this is 25 millimeter. I have bought something that is similar size to this, as in 35 millimeter or 38 if I'm not mistaken. Yeah, those are big puppies. Benefit of that will, if at lower ish RPM, let's say 1700 RPM, I should still get a lot of airflow, like a lot of oomph, and without having too much sound. These are industrial fans that I'm buying. So again, industrial fans are much cheaper. So you may, if you are in a scenario where oomph is the most important thing, look into industrial fans. Do not look into PC fans. If you have the luxury of PC fans, go YOLO on it. PC fans are awesome. And Noctuas, why do they charge so much more? Again, many of the designs, they did a lot of innovation there. On top of that is the quality control. Like, you pay for the quality control. You just buy it, you put it, and you forget about it. So that is why. So that would be the second part, where I'll design the basically better chassis in Fusion 360. Hopefully I'll have an electronic where I'll have an ESP32 with a potentiometer where I can throttle it down. And why have potentiometer? Well, A, it's the cheapest way of doing it, and B, simply means most of the time potentiometer will be at the setting where it's very low, as in, like, audibly it still has the work, but it's very low noise. And when if I need to do something that is, I know it's going to make a lot of gases, crank it up. That's why I just do not want to throttle it, or like just feed 7 volt or something like that. Again, that's why, like, I pay for the fan, I have the luxury of using it, and most of the time I'll get quiet fans. There are P12 max fans that are 3000 RPM. PC fans, again, too expensive in my country. If you can find it cheaply, that's are also a good option. Smaller also. So these are all the learnings I got from Mark I. Yeah, I thought I was like very clever with this cross braces, so I would require less 3D printing. Yeah, that part was true, but it was such a mess that it was just not worth it. Just not worth it. I learned so much in terms of 3D printing, like how can I make it into assembly design, which all of you can print and still get a very good experience. In terms of filter, that's up to you which filters is available in your area, but I'm reasonably sure. And be mindful, this is made for car Toyota Etios and Etios Liva petrol and diesel variant. You should be able to get something like this quite easily. So this is my current project that I'm working on. Hopefully you guys have liked it, learned from it something, and I'll keep moving forward. Like, this was part 1. Part 2 would be the design, the actual new upgraded design, and then the electronics would be the scary part, and then final product. So come along with this journey. I hope you guys have liked it, learned something from this video. In that case, thank you for watching, and I hope to see you in the part 2 of this. Thank you.